Hi, in this video I would like to show you how to automate WinDbg with JavaScript. We will use JavaScript to print a class name to a window handle when debugging user32 function calls. Nowadays, modern apps might not use native Windows controls, but instead render older content. However, there are still many applications that are built from native controls, so our example is not that artificial. The application we are going to debug is the Windows EventViewer. As it's an older application, it creates many native windows or native controls. We can find them using, for example, System Informer, which was formerly called Process Hacker, or Spy++. The benefit of using System Informer is that it does not require administrative rights. So let's have a quick peek at how both those tools display the process windows and how we may save this data for future processing. So I'm starting EventViewer, and then I run System Informer. And in System Informer, to find the windows that belong to EventViewer, we might use this little icon here that once we grab it and then select the window, it highlights it. And it also picks the process to which a given window belongs. It's here at the bottom, mmc.exe, so that's a host for those various snappings in Windows. EventViewer is just one of them. So if I double click on it, I can go to the Windows tab, and here are all the windows that are controlled by threads in this process. So we can see that the list is quite long. There is no save button. However, we can, with Ctrl A, we can select all the windows and then copy content of this tab to, for example, a text file. So I can run a notepad and then paste the content here that I copied and save it at, for example, ctemp then Windows systeminformer.txt file. So that's one way how we can collect information about Windows and the handles, class names, and so on. We can see that System Informer is quite detailed about what it shows us about a given window or a native control. Except for the handle, we can find its class name and also the title and the thread that's executing the window procedure. Now, the other tool that probably many C++ developers know well is this Spy++ or SpyXX. It does require admin rights, and it's installed by default with either Visual Studio or Visual Studio Build tools, and we can run it by executing SpyXX. It requires admin rights, so that's a big difference. And the look of it is quite dated, but it also shows us a nice hierarchy of windows. And by using this button in the toolbar, we can find the window which is visible on the desktop. So for example, here I can grab this icon, then go over the EventViewer window and then pick one of those windows. It will show us the handle, and then once I press OK, it will bring us to the right window in the process tree. To save informations that are visible in the window tree, we can use the Save Tree to File button, and that creates an SXT file. So I will name it just Windows, and then so that's spyxx.sxt. We are going to debug EventViewer. So we are going to record a time travel debugging session of the process of resizing this window, and then we will try to find calls to one of the window functions from the user32 DLL and decode the title and the class name of a window handle. So let's prepare the time travel debugging session. I need admin window for that, so I opened it here. We are going to record our trace in the temp folder, and to install the TTD client on your system, you can either use one from WinDbg. It was available in quite some time ago, but nowadays I think that the better choice is to use the command line utility, the ttd.exe, which you can install from Microsoft site. There is a link to the APX package, or there is even a PowerShell script that you can use to download and extract the binaries. And the PowerShell script is a good choice when a system, when you need to use TTD, does not support APX extension, like for example Windows Server 2019 or older. And I also prepared a little guide on the wetrace.net, which shows you various techniques that you could use with TTD, including the way how I install this client and also how I attach to the processes. So let's now go back to the command line and do the attach. So one of the parameters is the out parameter when we defined where our trace file will land. So in my case, it will be the temp folder. Then we have multiple options here. We could either run the monitor, which is a fantastic way of collecting traces for running applications and also the newly started ones, because when in this mode, TTD will monitor the newly started processes, and if the name matches the parameter, then it will automatically start tracing it. One thing that we need to remember is that when we are collecting the TTD trace, it gets bigger and bigger very quickly. So we should minimize the time for how long we collect the trace to make the size smaller. So now in the admin console, I will attach to the MMC process that, so 5844, and once attached, we need to wait a little bit. There will be a small window that will appear in the corner of the screen, and once this window is on, the recorder is recording events. And what I'm going to do is I'm just going to move the window, resize it. As you can see, when we trace using the time travel debugging, it slows the application significantly, just because it's collecting so many events at any given time. It might, depending on what the application is doing, it might impact the performance. So it's not really for performance troubleshooting, but rather for debugging or learning how the application works. So I will disable tracing, and our trace should be now in the temp folder. So if I go back here and then list the files, we can see that there is this mmco1.run. So that's the trace file. And we are going to load this trace file into WinDbg. So I'm going to open it from our ctemp, and then run, and then OK. At first, WinDbg will index this file, so there will be a new file created in the temp folder. If I list again, you might notice it's still indexing it, but once it finishes, you will see that it creates this additional IDX file, which is not necessary if you need to copy this trace to another machine for troubleshooting. It will be recreated based on the run file. In the next step, we are going to load some scripts that I prepared. They are available in my LLDX repository at GitHub, where I created the scripts folder, and the one that we are going to use today are from the LLDX.js and windowing.js. So let me open this file and then also this one. And so those are little helpers that I use in my debugging sessions. And one thing that how I configure my WinDbg is that I put those scripts, the JS files, in the path, and then WinDbg will be able to load them. So let's load the script just by using its name. So if I write script load, then LLDX.js, since it's in the path, you can see that it was automatically loaded. Then I also will load the other script that I have, so that would be the windowing.js. And the first command that we are going to use is a little helper that shows the statistics of various calls in the trace that we collected. It is under the hood, it is using the TTD object that is added automatically to the current session. So there is this TTD and then calls. And when we have this method, it returns the calls that were made during the trace to a given function. And what's great is that we can use wildcards here. Of course, if we put something like that, for example, then it will take some time to extract those information. So it's good to put some at least basic filterings if we are not sure what we are looking for. So in my case, I'm going to look for all the calls to the set window, then wildcard function, and let's first count them. So how many of them we have in the trace, and we can see that that's in hexadecimal, so we can actually convert that to decimal, and that would be 200, almost 300 calls to various functions. But I would like to know what are those function names. So for that, I could either use the group by here, or you might use the little function that I added to the LLDX.js script, which is called call stats. And just a little introduction to this type of automation for WinDbg. So since some time, it is possible to write JavaScript files to do some automatic actions in the debugger. We can define our JavaScript functions here and then export them to the debugging session using the function alias, or actually any function that does not start with those two underscores will be available. But when we have those function alias, we can call a given function using simply something like that. So call stats, and so we just call it as a variable, because this alias is actually a user variable that is available in our session. Another way of calling that would be this way, but in this case it behaves in a very similar manner as old WinDbg functions. The passing parameter to it is a little bit different. So I actually prefer to use the new way, so this way. And if I type again the statistics, I will ask for the statistics for the call to all those set window functions. And if I run it, I might add display graph. It will look a little bit nicer since we have a collection here. And since I ran previously this command, it was already now sort of cached, and we can see that now we have the function calls grouped by their names with information about the count for each function. And it's just a group by statement. So if we go back to this file and look for call stats, then you will see that we are simply running the calls, but also using the group by a link query. So for people familiar with C#, they will immediately know how this thing is built and how to use it. Since I'm interested in this particular function, I would like to know on which windows this function was called. So we are going to use the dx command again. So we are going to use dx -g and then current session like before, ttd calls, then user32 and our function, so set window pause, and that will give us access to to those calls. So from them, I would like to select few things. So I would like to select, so that's our call, and then I will create a new anonymous object, so that will be easier for us to query it. And I will show the clock time, which is the system time when the call was made. So system time start. That's actually, if we type tab, then it completes the command that we are writing. So that's a nice feature. Then I would like to see the function name, which basically we know here, but just to have it. And I'm going to extract the handle. So that's the first parameter. Then we can access the parameters collection by using the parameters property. And I will also add the time start, which is the time when the function started, but this time it shows us in the debugger format. So once this column is very helpful when we need to jump to this place when the function was called, and then we can display its call stack, and it will be this point in time when this function call happened. So if I run it, you can see that there's WinDbg showed us the first, I don't remember the default, but the first some number of calls with the information that I wanted. So for example, the handle. Now the question is, what this handle represents, what's the window title and maybe the class name, and can we extract it? And for that, I'm going to use the function that is available in the windowing.js. So there are a few of them. The first one is the load spy.xx tree, which we can use to load the spy++ actually tree that we saved from the spy++ tool. The other one is from System Informer, so it can parse the text file that we extracted from the System Informer, and that's the one that we are going to use. But before we use it, I wanted to show you one additional thing. So when you are writing those JavaScript functions, and well, it's not that of course we can make mistakes when we are writing them, and the very interesting feature of WinDbg is that we can actually debug those scripts. So we can debug JavaScript automation scripts inside the debugging session. And for that, we can use a function called, or a command called .scriptDebug. And if I just type the script name, so in my case, it's windowing.js, then I'm inside a JavaScript debugger in the debugging session. I can place various breakpoints here. And we can actually list the commands that are available here. So this inner debugger has a very similar commands as the main debugger, but here we are debugging our JavaScript code. So that might look a little bit strange, but let me show you how it works. So I'm going to create a breakpoint on this load system informer tree function. And you can see that the debugger was able to find it. It matched the line. It's at 76. That's the line number. And if I quit now, the debugger will be still there, but we just quit the inner debugging session. So now when I launch my function, so load system informer, actually I can try use tab, and it will go through those various functions, and then I need to pass the command line. So that's the one that we saved, which is, I believe, this one. Let's see if it works. So as you can see, we jumped into the JavaScript debugger. So although we are calling this function from the main debugging session, now the prefix here shows input, and we are inside a JavaScript debugger. If I press K, you can see that the call stack is a JavaScript one. And if I might step through this script like in the regular debug session. I can review the various variables that are viable in this session, and I can just execute this script. So let's, oh, actually I missed the path, so let me check what was the path where we saved our file. Ah, that was okay, so I just made a mistake. So we can quit, and oh, actually I was out of that session, so let's restart and load the scripts again. Load WinDbg.js, and then let's rerun the command that I wanted, but this time we're going to use the right name, so that would be Windows s_si.txt. So this time it should work fine. And WinDbg.js under the hood creates a hash map with information about Windows based on its handles. And the one function that we can use to find a window which corresponds to a given handle is the find window function, which is also extracted as an alias, and we are going to use it in our script. So let's rerun the command, the dx command that we had there, and now it will take a little bit longer because it's a new session. And this time we are going to, let's pick this handle, for example, and we can use it to extract information about a given window. So I can run something like that, and you can see that the find window function found the class name of a given handle. There's no title, but class name was resolved. So we are going to add this additional information next to the handle. So let me write something here. We will add information about class name. So once again, we'll use the find window function, then c parameters dot class name. I could create a pipe and save the handle and then use find window once, but for this case I will just type it here and call it twice. As it's using the hash map, it does not really take long to extract information about a given handle. So here we will type title, and this time if I run the command again, we can see that we do not have only information about handles, but also the class name and the title of a window. So we can see which windows were called with the set window pose function, so set window position, when we were resizing the main event viewer window. And that's it for today. So I hope that you will have a look at those scripts and play with them. The documentation is on the main repository page, so you can find examples how to use them and also what are their syntax. So thank you, and until the next time.